Okay, so we talk more about noise interference. Um, you can have interference with consumer electronics, other people's radios and TVs and stereos. Um, and also get external RF interference. We'll talk a little bit about proper grounding techniques. Uh, what you can do about electrical and computer noise. One of the things they don't seem to cover yet, which I think is a bigger problem than a lot of these, is LEDs. LED lights, especially some of the cheaper Chinese ones. Um, some of the things you can do with DSP filtering, depending on the radio. There's also external DSP processing boxes that you can add, and it does the processing on the audio signal and helps clean it up. Some line noise, in other words, AC line. A little bit about common mode current, surge protectors, and the single point ground panel. There's one of the questions in there I really have a problem with, but that's like the last one. We'll get to it. If you're doing single sideband, you may be causing interference on somebody's TV, radio, in the audio, and they're going to hear very distorted speech because they don't have a product detector, so they're not able to actually demodulate single sideband. They're just going to hear like what you hear when you're trying to tune it in or you're on the wrong sideband. If somebody's sending CW, that interference is going to sound like a hum from when the carrier's on and off, or key clicks, depending on how their wave shape is. If they don't have a nice rounded keying waveform, they're going to get clicking sounds. They might have clicking and hum.
My neighbor has some Wurlitzer organ. And every time I transmit it, it comes out real good. It sure sounds like you talking on our organ.
He can't understand you, right?
Yeah, exactly. If a consumer electronic design will build a perfect product, keep removing parts till it stops working, and then put that last one back. Yeah.
What sound is heard from an audio device experiencing RF interference from a single sideband phone transmitter? What sound is heard when you're doing CW? One of the things you can do, or have them do, is put bypass capacitors on the speakers to at least filter out the higher frequency stuff. And for ferrite chokes, which you just put on everything. Can't have too many ferrite chokes.
I just bought a little bunch.
Yeah, Amazon has a box of assorted sizes.
Yeah.
I've gone through a couple of those.
Computer stuff spewed out from their.
Oh yeah, computers are bad.
Like the charger for this thing is terrible.
Which of the following might be useful in reducing RF interference to audio frequency devices? Which of the following would reduce RF interference caused by common mode current on an audio cable?
Charlie. Charlie.
You like Charlie?
Oh, that will stop interference.
That's true.
That will definitely reduce it.
Well, I think it would stop it. Yeah, I really. They should add in there without affecting the desired signal. For grounding, You know, the standard thing is to keep ground wires as short and direct as possible. Every bend is makes it higher inductance. The longer it is, the more self-inductance. And also, they don't mention it in this part, but you really want to have as much surface area on ground conductors. That's why you normally recommend flat copper strap as opposed to round wires because it's got more surface area. So it has, due to skin effect, it has a much lower impedance.
Comment,
Connecting,
Bob. Comment, Bob. I found out the hard way. I don't think I did it, but I had electrolysis in the copper pipes in my foundation because something was grounded to it.
oh,
It's not good.
Had to have the concrete in my kitchen chiseled out to fix the leak, repair the tile. It was a big mess. So best not to use your water pipes as a ground.
right.
Yeah.
In fact, nowadays, modern houses don't have copper anyway. It's got that plastic stuff.
Correct. You know, it's the copper and cement, it's just inevitable off family.
You want to make sure that all the metal cabinets and closures are tied to ground. And you really want to do all these things to a single point ground so that you keep everything at the same potential so that you don't have any potential differences. Otherwise, you can have essentially a ground loop or a difference in potential, which can get rather high, especially if you got a lot of RF floating around.
I've searched for ground groups before and found them. Yep, they're there.
If you're getting reports of hum on your transmissions, it probably means that you've got a ground loop in your audio somewhere. And it's one of the reasons is some people just tie one thing to another thing to another thing. With a daisy chain ground, that's not.
Makes it great antenna.
Yeah. And everything is at a slightly different potential along the way. So obviously there's current flowing. Ah. All right.
Hey.
You think it's A?
Hey.
Doesn't affect SWR? How can effects of ground loops be minimized?
With Bob washers and cereal juice now.
I kind of like Charlie, although I thought it was just the opposite. I thought you should use lock washers and start.
Yep. He sounds safe.
What effect can be caused by a resonant ground connection? Charlie.
Yeah, Charlie. Nothing good.
Yeah, if it's resonant, it's going to look like a high impedance, and you're going to could get a significant voltage.
Yep.
What's a possible cause of high voltages that produce RF burns?
Transmitter output.
Is it Charlie or
Yeah.
Delta?
Yeah.
Why must all metal enclosures of station equipment be grounded? What technique helps to minimize RF hotspots in an amateur station? Broadband electrical noise, which is essentially a spark gap transmission, which is how we started with Marconi, or Hertz actually. So
Just to comment on grounding, I did some work for Bonneville Power Corporation long ago, and the guys that we worked with told about the safety preventions that they had. They had something like they talked about a grab potential or a step potential, but they had 2-inch copper plate floors to eliminate to keep the potential difference between two rubber tennis shoes, special issue, to below 300 volts when they had faults. So when they had a ground fault, it was a serious problem. Transformers the size of a freight car would explode.
wow.
Anyway, so grounding can be very important indeed.
Oh, yeah. We'll talk more about it on the last day on safety,
Yeah.
with the safety ground and some of those other things. On how not to do it.
We don't need no safety.
Huh?
We don't need no stinking safety.
Yeah, you got to cover that, how to climb a tower and all that good stuff.
You just call up somebody who knows what they're doing.
Well, but you might want to be ground crew. You have to have a ground crew, at least one.
That's the guys that catch the bolts with their hair.
Oh, it's your wife with a cell phone for 911.
It's following people.
But anyway, it's broadband transmission due to basically arcing or sparks. So you can get it from power line transformers around here. I think the most common cause, and the guy talked about it tonight with salt and stuff on the insulators on the power lines, and you can actually hear it and see it as you drive by. But just the insulators, we get enough salt spray that they start arcing over. And power companies sometimes actually go wash them down, hose them. It gets really in certain areas.
Sounds dangerous.
Well, yeah.
Here with the garden hose.
Yeah, they say you're not supposed to do that yourself with the garden hose.
Yeah.
It might de-energize it.
Might be electrifying experience.
It's like squirting fire starter on a fire. You're in good shape until you let up on the pressure and it comes this way. Which of the following could be a cause of interference covering a wide range of frequencies? Noise blankers again. Since they only work on impulse noise, they don't really help if you've got broadband noise at all. And if you're using the noise blanker, and I think one of the effects, because you're essentially taking a kind of a square wave notch out of the signal, you're actually, creating a waveform that's going to generate additional harmonics.
Yeah, I've had it where it is power line noise and it's really heavy. You put it on, put some of the holes in the signal, and it gets kind of curved. But it's a big difference between understanding or not.
Which of the following types of noise are removed by a noise blanker? What undesirable effect can occur when using a noise blanker? DSP noise reduction. This is I guess these things are still around. They used to be popular a while back. This Time Wave made DSP processing boxes. They weren't cheap either. But it can filter out a lot of broadband noise and even ignition and power line noise to some extent.
Is that working on the audio?
Yeah.
Okay.
And even in your SDR, you're pretty much doing it on the audio or or the IF, which is close to audio. Which of the following types of noise can often be reduced by a digital noise reduction? All the above. If your receiver has an automatic notch filter or ANF, okay, it will try to place the notch where it thinks the interfering signal is. The problem with that is it can outsmart itself on CW and actually take out the CW signal because it thinks it's noise.
Yeah, that's gonna be wrong.
I knew you were going to say that. There's the thing again showing the result of having the notch filter in there. What problem can occur when using an automatic notch filter to remove interfering carriers while receiving CW signals?
Should remove all.
That's that short center, it's not their ground.
Even though you can do all kinds of filtering to get rid of stuff, it's better to get rid of it where it at the source. So you kind of try to find out where it's coming from. One of the typical sources is any kind of thermostatically controlled device where you've got switching contacts like house thermostats, switch on and off, a lot of different control things. I have a heater that I use to keep filament dry for my 3D printer, and you just set a temperature on it and it does one of those, and every time it switches, I'll hear it on the radio. Doorbell transformers are a big problem. Neon, this says illuminate, really neon sign displays generate a lot of noise.
The old precedent.
Yeah. And then they left off LEDs.
Oh, yeah, that's the new, that's what's in place, the precedent.
There's no better, noise generators.
If you've got AC noise interference, you can use some of these line suppressors. It's kind of a pi or T filter or a little bit of a mesh in there. They're fairly effective. You just have to get one for the current rating that you need. And that as the current rating goes up, they obviously get more expensive. Which of the following can create intermittent, loud roaring or buzzing AC line interference? What is used to suppress radio frequency interference from a line-driven AC motor? Just think brute force. Because if it's your air conditioner, there's not a whole lot you can do there.
Well, those are now DC motors, usually the switcher.
Yeah.
It's.
Common mode, okay. You can have current on the outside of the shield of your coax, or if you have other unshielded cables or conductors, you can get common mode current on any of those. The only place you don't get it is on the inside of coax, but you can definitely have it on the outside. This is just showing a dipole and coax, and you're feeding it one side grounded over here. If there's any imbalance in the current, like your elements are not equal, they're not horizontal, things like that, or other signals coming in, the current on the inside of the coax is going to be equal and opposite. So if I've got 1 amp on the center conductor going down, I've got 1 amp going up. Any difference in the current is going to be on the outside of the shield because it actually looks like 3 conductors. The center, the inside, and the outside because of skin effect and the fact that charges try to repel each other. That's why it forces it to the surface. So if you put something like a ferrite bead toroid on the outside of that cable, okay, that increases the impedance of that line, so it reduces the amount of current flow. Now, there's always a question of when you do that with a current choke, do you put it at the antenna or you put it at the transmitter? I've heard both.
Yeah.
So easy is put one on each end.
He says.
Well, wait a minute though. If you have an end-fed half wave, the coax is part of the antenna. And so it cannot go up at the coil. It has to go down at the bottom.
That
Yeah, I think it's correct. Yeah.
that seems to be true with the end-fed whisperer guy. There's a lot of YouTubes, and that's what he recommends. But so which of the following can cause shielded cables to radiate or receive interference? What current flows equally on all conductors of an unshielded multi-conductor cable? When we talk mobile, okay, the main source of noise is your alternator, or if you really got an old car, generator with brushes.
Voltage when it hits mechanical voltage reading.
Yeah, yeah. Once again, here comes ferrite chokes. And just put them everywhere. I think in the previous question pool, they recommended capacitors on the ignition coil, I think, but they've taken that out.
See it when we turn on the alternator.
Yeah. And they used to make special ones just for that purpose. They had a little ground strap on the capacitor and a lead coming out. Special made for it.
Yeah.
Well, nowadays they're using coil and plugs a lot. And
Right.
it's not mean, okay.
How can conducted noise from an automobile battery charging system be suppressed?
So.
Personal computers, laptops, basically any digital device. It's probably going to generate a lot of switching noise. So this sounds like a bunch of modulated, unmodulated noise, no particular frequency necessarily. What type of electrical interference can be caused by computer network equipment?
Yeah, true. It's just like.
That last one, the Delta answer whining noise that cycles on and off, kind of sounds like teenage kids.
Switching mode power supplies is another source of interference, but it's going to be normally a fixed frequency and you're going to see harmonics of it. So whatever the switching frequency is, say it's 100 kilohertz, you're going to see that spike every 100 kilohertz for.
It just comes with a big long jagged line.
Yeah, you can switch, keep going up in bands and you just keep seeing it. I've seen that a lot. But then there's another one. Nobody's ever told me what it is. Every once in a while, you'll have some signal that just sweeps across the bands.
Oh, I see.
Yeah.
That's line.
I've seen the fire zone.
Huh?
Coaxial lining, like cable TV systems.
Really?
They'll drift and yeah, they'll sweep, they're like dozens of megahertz.
Yeah, I mean, it doesn't matter what band you're on, you see it coming by.
Yeah, that's noisy amplifiers that are re-radiating, when they're not supposed to be.
Also,
Common problem across the country.
I was told that those are also, frequency or transmitters that transmit a sweep of frequencies to detect, reception across a particular band.
Propagation.
Yeah, that's right. Propagation.
Hmm.
And if you hook up your, antenna analyzer to your antenna, it will do the same thing, but it doesn't.
Well, yeah, it is doing a sweep
Yeah.
on purpose, but.
Right.
So what causes interference received as a series of carriers at regular intervals across a wide frequency range? One of the other sources can be a corroded bolt or bad connection. Even a loose connection on coax, where it can actually act as a mixer and create these intermods and retransmit. So you get the normal frequencies and the sum and differences and the harmonics of them, just like on the chart I have that's, well, no, we had that one. We don't have the third order one. Gotta find out where that went. What could be the cause of local AM broadcast band signals combining to generate spurious signals on the MF or HF bands? Proper grounding is essentially having a single point ground panel where antenna, feed lines, things like that come into your shack so that everything is at the same potential at that point. The part I have a problem with is this last line where they say that one of the reasons is you mount the lightning protectors or surge suppressors on that single point panel, so they all activate at the same time. I somehow have a problem with believing that,
Physics don't make sense.
but that's in the answer to the question.
They're totally different antennas.
I mean, they're going to be, it could be different paths. I'm not sure where they came up with that.
I can tell you, broadcast facilities, they don't install lightning protectors on the ground panel. It's a panel on the outside of that wall or something. All the stuff comes into it, and there's ground wire straight down. All the surge suppression and stuff like that on power is all inside, connected almost in short stubs directly off the turn on circuit breaker box. Installing that stuff outside.
You're not supposed to put them on inside, for amateurs at least, because that means the lightning is getting inside.
Well, okay, if you're talking like RF surge suppression, yes.
Well, we're talking about lightning arresters. Yeah.
Line stuff. I guess the question is are they talking AC surge protectors should be mounted on this panel? That's what I'm saying. Is not.
Yeah, and they're saying lightning protectors on the. Now I believe it should be outside,
Right.
and I don't have a problem with mounting them on the single point panel, but have it, the reason you do it is for them to activate at the same time. I don't believe.
Unless they're thinking that one of them would be. Just thinking electrically, if one of them shunts to ground or open basically, whichever the case is.
Yeah, normally it's a gas tube and it just
Yeah.
fires.
Then the question is, would it actually give it the opportunity for
lightning to take another path somewhere else, or a surge to take another path before the other one blows.
I don't know.
That's
This-
not in the regrounding tracing. Not the reason for it.
So what's the purpose of a single point ground panel?
Previous slide is built.
Yeah, that's why I have a problem with this,
It seems some problem. with that.
but
Especially if it's not.
yeah. I mean, of all the reasons to do it, that seems like the least.
I'm thinking of protecting each line.
It's common ground potential, so you don't end up with voltage differentials.
You're not gonna have ground loops in your ground.
Yeah, that's the idea, is if you've got multiple ground points. That would seem to be the focus of what that should be coming from, is you have a single panel.
I don't know.
Start point distribution.
I
Hey,
don't
Bob.
understand. Yeah,
This is an example of picking the least atrocious answer.
right.
Pick the least bad answer.
Oh, yeah.
Yeah, I don't think that's a very good answer, but he's right. It's the best of the bunch. Where should a station AC surge protector be installed? You're really loading up your single point ground panel. My surge suppressors aren't on it.
Yeah, they're places.
I could only afford about a 10 by 12 one. Quarter inch copper.
Oh,
Cost a bunch. Okay, so we talked about SSB and CW interference on consumer, audio devices, basically. What to do about external RF interference, ground loops, bonding everything together, tying it to a single point ground, where broadband noise comes from, the use of noise blankers and the fact that they can actually distort signals. DSP filtering and noise reduction, which works pretty well, but it can outsmart itself and get rid of your CW signal, which Ed doesn't care about. And line,
in favor of that.
you turn it on all the time and talk about common mode current on the outside of the shield or on unshielded cables, alternator noise in automotive. I guess today that's probably the biggest problem, although I think the computers in the cars are pretty well shielded.
Hybrids or electric cars, and you've got motors in there.
Well, they're not taking into account Teslas and stuff. But there's not much switching going on, but they are generating, I assume those are three-phase motors, DC motors. Yeah, well, you generate 3 phases from DC. No, steppers 2.
Their HVAC almost the DC square wave essentially.
Steppers 90 degrees out. For most of them.
They're very high voltage,
What?
the motors in the Tesla.
Electric cars? Yeah, they're, I guess, a couple hundred volts. Well, let's keep the current down, otherwise you'd have to have. Right. We talked about the corroded metal joints re-radiating, and it's a real thing. In fact, we have a problem like that on the I guess it's the 3.7 repeater, and they did a workaround by putting the tone on the receive side. They still need our 3.7 repeater up in Cocoa. Still need somebody to climb up the tower and find it. There's apparently a rusty bolt somewhere that's causing that interference. You volunteered to climb? Oh, okay.
How tall?
The tower is 300, but from what I understand, the repeater's at 200.
Yeah, it's lower.
But couldn't the lower joint be anywhere on that tower?
Yeah.
It could be within
Yeah.
several feet, yeah.
As long as it's less than 450, 420.
Really?
I used to find 400.
Yeah. You're braver than me.
Yeah, I loved it.
No, I don't like heights.
And it's quiet up there, you can see.
I get up to 30 feet and then he will be here.
Swing your base jumping.
On the hottest days, it's nice and cool.
No, I never got comfortable with that.
Oh, well, yeah. You can take one of the beacon lights, light bulbs,